Okay, hello everybody. This video is going to be a brief memory refresher on structure and properties of hash tables, as well as a walkthrough of question 2 on the worksheet. So if you haven't watched lecture, go watch lecture and then come back and watch this video. Okay? So hash tables. They are arrays of linked lists, right? This is the picture that we want to have in mind whenever we are doing hashing, okay? We call each element in the array a bucket, and each bucket stores a pointer to a linked list. Hash tables have a constant lookup time. We need to know the definition of load factor. The load factor is defined to be the number of elements over the number of buckets. Now, why do we have a load factor? Well, it's going to tell us about when we need to resize. So when a load factor reaches a certain value, a certain threshold, we resize our hash table, okay? And that value it can be determined by us, okay? Or it might be given to you in the problem. Okay, now let's jump right into problem number 2, hash tables. You are a software engineer for a ticket selling company who wishes to find a more efficient way to store customer information than using a simple array, and you decide to store info using hashing with singly linked lists. Design a put method for ticket table to work properly. Assume a load factor of 3. Okay, let's look at the code that they give us, and let's take note of the fact that a customer has a hash code method. And in this case, it seems like they're using ticket ID as the hash code. A good exercise for you right now, independently, would be to ask yourself, is this a good hash code? What are the properties of a good hash code? This is a good understanding check. Okay, we also have a ticket table class, and it seems like right here we're creating our hash table, keeping track of the number of buckets, number of customers, and we're given a resize method. We don't have to implement it, it's given to us, so maybe we can make use of that later. Okay, we're ready to start writing our put method. So before we actually start putting things into our hash table, we need to take a look at the load factor, and we need to see if putting Fred is going to cause us to meet or exceed that threshold. So remember, they told us to assume a load factor of 3. And remember that a load factor is defined to be the number of elements divided by the number of buckets. Okay? So let's put this into code. If, after I add Fred, right, if size plus 1, divided by bucket, number of buckets. If this is greater than or equal to 3, my load factor, then I need to resize. Okay, so now that's dealt with, we are good to actually start putting, okay? So I need to figure out, I have this hash table, right? And I have, this hash table has some indices. I need to find the appropriate index for Fred. And the way that I do that is, what tells me where to put something in a hash table? Well, the hash code, right? That's the whole point of all of this, right? The hash code is going to tell us where something belongs. But here's the thing. We can't just use the hash code function and then assume that that's the correct index. Why? Well, okay, we have a ticket ID, and think to yourself, a ticket ID could be super long, right? But our hash table is not necessarily going to have this many items in it, right? So we want to get an index that's actually valid. So an index within the range of 0 to n-1. And the way that I can do that is I can take advantage of modular arithmetic and mod the ticket ID by the number of buckets, okay? Because this will give me something within the appropriate range, okay? So how am I gonna do that down here? Well, I'm gonna start off by saying that customer C is equal to heads, which is the name of the hash table, which is the name of the hash table, at what index? Well, Fred.hashcode mod bucket n, because that's the number of buckets. Okay? Okay, so now there's two cases. Okay, so let's say that this was my hash table. And let's just say that this right here, this box was, or this element happens to be C. There's two cases, right? C could be empty. There could be nothing in that bucket. Or there could be, some linked list of, some length, right? Okay, let's first consider the case that there's nothing in that bucket. If C is null, then what? Well, I mean, my job is pretty straightforward if there's nothing in C. I just have to add Fred to that index. Now, what about the case where I already have some stuff in there? I already have a linked list going. Well, in that case, I need to work my way towards the end of the linked list and add Fred at the very end, okay? How would I go about working my way towards the end of this linked list? Well, while C.tail is not equal to null, while there's still another element in the list, C will be equal to C.tail, okay? Working my way through here. Now I can, once I've worked my way through to the end, I can tack on Fred. Whoops, sorry. Okay? And of course, anytime that I'm putting, the last thing that I have to do is increase the size. We can quickly summarize the process of putting something in a hash table. Okay, so 1, resize, or I guess I'm going to actually say check load factor and resize if needed. Number 2 is index into correct bucket. Number 3 is add item to the bucket. And that's it. That's how we put. Oh, and then lastly, increment the size. Okay, I hope that this video was helpful, and that's all.